Okay, good afternoon, everyone. Welcome to this new UEF. So today's meeting is the scientific presentation will be on the monitoring, forecasting, and assessing the impact of floods done by one of our colleagues, Stefania Grimaldi from the GRC. And before that, just maybe a very brief update of and news of the ClimSA Station from the last meeting. So maybe Vijay, you can.
Hello everyone. So quick update is we created some of the specific Jupyter notebooks for each of these thematic specific things. Like last time you saw the climate projection Jupyter notebook, and also now we created a GLOFAS specific, the product specific Jupyter notebook, which can be utilized in the ClimSA Station. But I let Stefania to first present about the introduction of a GLOFAS system. Then I show you how it can be used in the ClimSA Station. So that is a basic update, and also later we can see, because some of you contacted, wanted to have some more information, but I wrote you all, but I haven't got the response. So this can be again dealt at the later session this evening. So that's it from my side. Thank you, Gustav. Over to you.
Okay, thank you, Vijay. Yeah, I mean the last meeting was just last 2 weeks ago, so of course there is no big news in between the two last meetings. Okay, if Marco, you don't want to add something, we can go ahead with the second part of the meeting, which is the scientific presentation. Marco, if it's fine for you.
Yeah, it's indeed fine. Thank you. Welcome everyone. Nice to see you at this meeting. And without hesitation, I would give the floor to Stefania, I think, for a presentation.
Okay, so thank you, Marco. So Stefania is she's working in a different units, but at the GRC, and she's working on in the GLOFAS team that was introduced very quickly by Peter for those that attended the training at the GRC in April this year. And now Stefania we will present a bit the different products that could be useful for monitoring or forecasting floods. Stefania, you can share your screen, and the floor is yours.
Thanks, Christophe, and thanks, Marco and Vijay, and thanks everybody for attending this meeting. It's really a pleasure to be here. I'll try first to share my screen. Okay.
Okay, you just have to put on the presentation mode and it should be okay.
Should be in presentation mode now?
No, it's not yet in presentation mode.
Okay.
You have two screens?
No, just one.
No, we don't see. Or maybe you have to share instead of, because sometimes it depends if you choose the entire screen to share your entire screen or just an application. Maybe sometimes the entire screen is working well, better.
Let's try the entire screen then.
Yeah.
Okay.
There we go. Perfect.
Okay, thanks. Thanks a lot. So thanks for the introduction. This presentation will present an overview of the Global Flood Awareness System. The Global Flood Awareness System is one of the products of the components of the Copernicus Emergency Management System, which actually entails 6 different big components. We start from on-demand mapping, and then we go through early warning and monitoring for events such as floods, fires, and droughts. And we also have exposure mapping to understand how population and build-up areas are spread all over around the world. But this presentation will just focus on the flood component of the early warning and monitoring, and specifically on the global flood awareness system. This system is an early warning system, meaning that it provides complementary information to national and regional services. It has the aim to support both national and regional services, but also international organizations in order to make decisions based on forecasts of upcoming flood events. It provides probabilistic forecasts, and all the products and data are freely available in real time. But what are those products and data? So first of all, GLOFAS provides global hydrological ensemble forecast updated every day with daily resolution at 0.05 degrees all over the world, which is roughly 5 kilometers. And this was a big change that we actually introduced on the 26th of July of this year. So it's not even 1 month, because the previous system had resolution 10 kilometers. Now we actually have forecasts globally at 5 kilometers resolution. The purpose is to highlight the expected flood events over the next 30 days, and also to provide information about flood extent and rapid impact assessment. GLOFAS also provides seasonal hydrological outlook for the next 4 months in order to show the anomaly in terms of wet or dry conditions. And it also offers a number of additional pieces of information that help to analyze and understand and also actually assess the accuracy and the reliability of the forecast. This is because, as I mentioned before, GLOFAS is aimed to be complementary to national and regional services. And it is the authorities and it is the local experts that actually have the task to evaluate if the forecast is reliable or not. And in order to help the local authorities, the local and regional authorities to do so, we provide a number of additional pieces of information. And in this presentation, we will have an overview of all these products. We will also explore very briefly a new product, which is the global flood monitoring. So starting first on a bit of an explanation of how GLOFAS works. We said that GLOFAS provides hydrological forecasts, and in order to do so, the forecasts are based on a hydrological model, which is called ListFlood open source. So it's also open source, that provides information of all the hydrological states, soil moisture, snow accumulation, but especially discharge, for each pixel of the computational domain and with daily resolution. The hydrological model is forced with meteorological input forecast. And for instance, for the seasonal forecast, we use CA5 and so on. We also used a set of static maps which show the information of morphology, soil properties, land cover, and land use for each pixel across the world. So this hydrological model takes information also on the local characteristic of the catchments in order to produce reliable forecasts. This is a global model, so of course it has to be calibrated. And in order to calibrate the model, we use observed discharge time series. So in this slide, we saw in a nutshell how the discharge forecasts are produced. So we have the meteorological forecast, then the hydrological model, which runs daily with 5 kilometers resolution. And as output, we have the river discharge forecast. The river discharge forecasts are represented by hydrograph. We see in this slide on the top right an example. And we see, for instance, in this case, that the forecast over the next 30 days was predicting an increase of discharge. We will see briefly later on what the colors mean, and then a decrease of the same discharge. If we zoom out a little bit, we will see that in catchment, we might have several points along the river network where we have a signal of increase of discharge. And these points are actually visualized in the map, and we call them reporting point. In the figure on the bottom right, we see a number of triangles, purple, yellow, and red, which actually show a signal of the flood event, which is coming in the next 30 days. This is, of course, relevant piece of information, but we also want to complement it with information on potential flood extent. Maybe, okay. So with potential flood extent. So we run also an inundation model, and we produce a catalog of flood extent areas in order to see actually where the flood water are having an impact. We then overlay this flood extent map catalog with exposure information in order to provide an assessment of the potential impact of the event. So with the product that we call rapid impact assessment, which is then a combination of the magnitude of the event, of the lead time, so if it's coming in the next 3 days or rather a little bit later, and also of the potential number of people and critical infrastructures that are affected by this event. Of course, in order to provide reliable information from the discharge down to the rapid impact assessment, we need a hydrological model that performs quite well in order to reproduce the discharge information. And here in this slide, we have an overview of the performance of the hydrological model in the newest implementation, which was released on the 26th of July. So in each point of this map, we have a calibration point. The model was calibrated using in situ discharge measurements, and we also implemented a regionalization for areas for which we don't have discharge data. So for each point shows the performance of the model for the calibration. The performance metric is the KGE. KGE is the best when we get values very close to 1. Reliable values are from minus 0.41 up to 1. So any point with a color from purple to blue, it shows that the model has scale. Of course, light blue and blue it's the highest scale. Points with black, which are in black, it's actually where the model does not perform well. And this could be due to several reasons. For instance, the presence of a lot of dams, so it's highly regulated flow. You will also notice some white points here in this map. And this is because it's an additional piece of information, because the KGE, which is our metric, it's actually the summary of 3 metrics: the bias, the correlation, and the variability. The correlation indicates whether GLOFAS is able to capture, to actually get a flood event when it's coming. So if the GLOFAS discharge forecast goes up and down as the real forecast. Since GLOFAS is our early warning system, it is important that we are able to get the signal right. In these white points are those points where maybe the magnitude of the discharge is not really well reproduced, but the signal of the discharge is well reproduced. So these points is points that we can still use at to do flood forecast, but we cannot rely on these white points if we want to look at the management of water resources, because maybe the forecast is largely overestimated or underestimated compared to the real discharge. So this is in a nutshell how the system works, but I would like to share more about the products and what we can get out of the system. First of all, we can have an overview of the GLOFAS medium range forecasts, which are updated, as we said, every day, and provide an overview of the next 30 days. We already saw once the discharge hydrograph, which is here represented on the top left. And now we can focus a little bit more on the pieces of information that are provided by the flood hydrograph. So the forecast starts here after the blue point, and then we have the information for the next 30 days. The box plot represents the uncertainty of the information. So the larger is the box plot, the larger is the uncertainty. And the colors here in the background are the threshold. So green is for 1.5 years return period, to 5 years, and purple 20 years. These thresholds are based on the climatology. So it's important to remember that these thresholds are not based on local information, but they are based on the climatology of the model itself. This approach is important because we want to provide information all over the world, and local information about flood thresholds might be available just for a few catchments or a few points in the same catchment. And it is also important because by using the climatology to establish the threshold, we remove the model bias. This is the information for one discharge hydrograph, so it's of course connected to one specific point. If we want to have an overview of what's happening in one catchment, we can use the flood summary layers, which are represented on the right here in this slide. So the flood summary layer is a layer that provides information for each pixel of the river network. In each pixel, we have a color, which can be between yellow to purple, to show what is the threshold that is likely to be exceeded over the next days. So we can actually follow the flood event from upstream to downstream to see if the magnitude is increasing or decreasing. The lead time of these flood summary layers is in 4 different options. So we can have 1 to 3 days, 4 to 10 days, 11 to 30 days, or the entire forecast period, which is 1 to 30 days. So depending on which layer we switch on, we can have information on flood events which are forecasted to happen very close in time or a little bit later in time. If we overlay on the flood summary also the reporting points, we can now investigate a little bit more what all those symbols mean. So in this map here on the left, we have the flood summary layer, so the river network with the colors yellow, red, or purple, but we also have a number of triangles. Each triangle is called a reporting point. We have static reporting points, which are always there regardless of the flood event, so also in low flow periods. And we have dynamic reporting points that actually pop up only when there is a heavy flood signal. The points are colored in yellow, red, or purple, depending on the magnitude of the forecasted event. And I also would like to underline that the border of the points actually have a meaning. So when we have a black thick border, it means that the peak of the event is coming in the next 3 days. So that's an event that deserves to be looked at very soon. When the border of the triangle is gray, the peak of the flood event is forecasted between the next 3 and 10 days. And when the triangle itself is grayish, the event is forecasted after the next 10 days. So it's later on. Of course, the advice is to keep monitoring that reporting point to check if the signal is confirmed by the next forecast. The triangle can be upward when the discharge is increasing, downward when the discharge is decreasing, and it's a circle when we are basically right at the flood peak. So if we click on each one of these reporting points, we get our flood hydrograph. But not only, we also get more information about the reporting point itself with a description, and with also the indication about the probability. And we also get what we call the persistency diagram. The persistency diagram shows the last 6 forecasts. And they are important because they help to monitor how the forecast behaved over the last days, meaning that we can see if the forecast was consistent. And this is important for some small catchments where we can have a random signal of the forecast popping up one day, which is actually which disappears the day after. So it's important to see if the forecasts were confirmed day by day to assess if the signal is reliable. As mentioned earlier, we then use this discharge hydrograph to inform a flood inundation model to produce flood extent. These flood extent are computed offline by a hydraulic model, and they are then showed in the forecast. They have 100-meter roughly resolution, and they are computed for basin larger than 2,500 square kilometers, and only if the return period is larger than 10 years. For when we show this flood extent map, we don't consider the flood defenses. This information is then combined with the exposure in order to provide the rapid impact assessment. So the rapid impact assessment is this colorful layer from yellow to orange to red that shows the potential impact of the flood event in the next 30 days based on when it's happening, lead time, so it's happening very close to us, and the magnitude, and also the exposed population and infrastructures. In this case, when we click on the map, we have a pop-up window which shows us all these details about the potential impact. So it's actually you have details about the cities that can be affected, the number of people for 2 scenarios, protected and unprotected. If, of course, there is, we don't have information about flood protection in the area, the 2 scenarios provide the same piece of information. Now, moving on to the seasonal hydrological outlook, we can also have an overview of the products. And this product is updated every month around the 10-12 of each month for the next 4 months. There are 3 main products. The first one is the basin. It's the basin overview map, which shows colors between light blue to orange, and it provides a summary of what's going to happen in the next 4 months, looking at the most critical condition. So it's the anomaly compared to the climatology computed for that month, and it's also the most critical condition. So if you have a flood event coming up, well, according to prediction, the prediction which is coming up in the 4th month, and it's a huge flood event, you will have a blue area in your basin. So it's always the most critical solution. However, this information, as you can see, is kind of it's a kind of a coarse resolution. If you want more granularity and more detailed piece of information on your catchment, it's recommended to use also the river network. With the river network, you also the same information. So the anomaly compared to the climatology in the next 4 months, and also always the most critical solution. But it's interesting to see, for instance, that in some catchments, especially large catchments, you will have some rivers that are blue, so more discharged than usual, let's put it this way, or orange, less discharged than usual. Where it's gray and where the map is the basin is white, it means that the model is predicting conditions which are consistent with the climatology. If we want to dive in a little bit even more in the seasonal forecast, we can click on one of these black points, which are called the seasonal reporting points. When we click on each one of them, we actually see the forecast of the discharge for the next 4 months. So we have here on the top left, we have with the dotted line, the climatology. And then with in shades of blue, it's the 80 percentile of the climatology, and in orange, shade of orange is the 20 percentile of the climatology, while in shades of gray we have the forecast. So depending on how the forecasts place themselves compared to the climatology, we have the scenario which could be drier than usual or wetter than usual. And similar to the other reporting points, we also have persistency diagrams which show the latest forecast for the last 4 months. So you can also check if this signal was confirmed or actually completely changed by the last forecast. Now, let's briefly have a look at where you can find all these pieces of information. Our main source of information is the GLOFAS map viewer, which is accessible under the link that you see there. And I would like also to stress that there is also a contact form for any sort of question or any sort of doubt that you have about GLOFAS. In the map viewer, you will find not only the information that we discussed right now. So this is just a screenshot of the map viewer, how it looks like. You have the map of the world, and then on the top, you have a bar with a number of tabs. All the pieces of information that we discussed so far are under the meteorological, hydrological, and flood risk. So it's about forecasts. However, there are a number of other tabs that provide additional piece of information that can help to analyze the forecast and to assess whether it is reliable or not. First of all, we have the initial condition for precipitation, temperature, soil moisture, and snow cover. And these provide information over the last 3 days and over the last 1 day. So you can see, if you see a flood event forecasted in your catchment, you can check what was the precipitation in the previous 3 days and see if this actually is consistent with what you observed in your catchment. Similarly, you can also check the initial soil moisture, because that affects a lot the hydrological response of the catchment. We also have anomalies to show if the initial conditions are in line with the climatology or wetter or drier compared to the climatology. Another very important layer tab that helps to assess the quality of the forecast is the evaluation. Earlier on, we discussed the performance of the calibration in terms of the performance metric KGE, and this layer actually provides that piece of information. So you can see for each point inside your catchment if it was calibrated and what was the result of the calibration. Here you have colors that go from gray to blue. The darker the blue, the higher the performance of the model. But it's not only the point, we can also click on the single point to actually see the components of the KGE. So we can see if the catchment was calibrated, but also see what was the results in terms of correlation, bias, and variability. And for instance, there are some catchments where the KGE might be low, but then when we look at the correlation, the value of the correlation is quite reasonable. So this can help still to consider the GLOFAS forecast as reliable. The last set of additional information is underneath the static layers. And here we have information about reservoirs and lakes. At the moment, we only have very large reservoirs and very large lakes included in the hydrological model setup. So if in your catchment, you know that there is a reservoir that highly affects the discharge, but this reservoir is not shown in this static layer, it means that it's not included in the model. It means that the forecast is not taking the impact of that reservoir into account. And that is also clearly a problem in terms of forecast. I can anticipate to you that after a large number of requests from our users, we are working to increase the number of lakes and reservoirs that are included in the hydrological model setup. Another interesting layer to look at is the hydrological model network, where we can actually see the river network as seen by the model. So we can see the upstream area, and we can see also what is the spatial resolution of the model. I will now briefly introduce the newest layer, which is available from GLOFAS. We actually now jump into the monitoring part of the event. So far, GLOFAS was only dealing with the forecast, but we also have now a layer based on that provides monitoring. And this monitoring is based on satellite-derived information from Sentinel, from radar information, Sentinel-1 Copernicus satellite. And we have a number of layers that provide the observed flood extent as a difference compared to the observed water extent. For observed water extent is the water that is always, it's lakes and reservoirs, water that is always, let's say, visible in the model, in the catchment, while the flood extent is the water that is inundated the floodplain and the areas. This flood extent is derived from Sentinel data. So whenever there is a Sentinel-1 satellite acquisition, and the target is to provide the information 8 hours after the Sentinel-1 overpass. It has a 20 meters space resolution. At the moment, as you know, there is only one Sentinel-1A satellite on orbit, but so the frequency of observation is related to this one satellite, but it is foreseen that there will be a second satellite, Sentinel-1C, soon on orbit. So the frequency of acquisition and the frequency of the information that will be provided by the monitoring layer will increase. Finally, I know that I was very quick, but I would like to actually tell you that there is extensive documentation and also extensive user support on the products that you see in the map viewer, but also data availability. So we have a user guide to find out how you can download the data. And for one of the options is the option that Vijay will show you very extensively just after my presentation. But you can also get the raw data from the Copernicus Climate Data Store or from Mars, or you can get a tailored FTP to receive the data for your area of interest. In terms of documentation, we provide a user guide, which is a step-to-step guide. So it also shows where to click on the map viewer or how to use it in order to retrieve the information that you need. Then we have what we call the GLOFAS wiki for the description of the models of the products. So it's including the science which is behind the products and the model. And as we just saw, the user guide, data user guide, sorry. GLOFAS is really pretty much based on the response of the users. So we have annual meetings and webinars, which we make available via the GLOFAS webpage. We do a survey every year, and based on the results of this survey, we shape the next developments in GLOFAS. And we also always seek for new discharge data to calibrate our model and improve the accuracy of our model. And you might also want to request a static reporting point for your catchment in order to be able to monitor the flow all year around. For all these interaction, please, there is the contact form that you find at the bottom of the page, and which looks like this. You will only have to put your email and then send us a message. So just some closing remarks. I want to stress that any development in GLOFAS is driven by the users. So the survey that we do every year is really important to us to gather information on what has to be the next direction. Then we try to implement it, we test it, we deliver it, and we try to assess the performance, and the cycle repeats again. Few words as a conclusion. GLOFAS is complementary, probabilistic, and early warning, and it provides information on upcoming and ongoing flood events at the global scale. It's really relevant for large transboundary catchments, and it's meant to provide information for riverine flooding. At the moment, we don't have flash flood, coastal flood, and urban flood modeling in the system. And as I just said, user feedback and collaboration is really essential to shape the system. And this is it from my side.
Thank you very much, Stefania. Thank you. It was a very interesting and I think useful presentation for our colleagues that could be that are already maybe and will be, I'm sure, users of this platform. And of course, we encourage them to more communicate with you for the feedbacks and for the to provide some feedbacks and to clearly identify the needs, their needs. So now we have a question answer session related to the presentation. So if you have any question in the audience, just raise your hand, and we can and Stefania will reply to you. And before we have question from the audience, I have two questions for you. The first one is related to the rivers represented into the model. Is there any minimum size of the catchments um, that where the model is able to get informations, and it's something related to that. The second question, I mean, the question related to that point about the number of rivers represented to the model, it was about when you show this calibration validation part. It's really nice to see the number of points for calibration in Africa. It's really a big improvement, I think, for the very recently, and for the calibration is of course extremely important. But for the validation, is there linked also in between the quality of the forecast and the size of the catchments? So when we saw these different colors in your map for the validation, either did you see a link in between the size of the catchments and the quality of the forecast?
Thanks for these are very key questions indeed. So in terms of the size of the catchment, for catchments above 500 square kilometers. And this is also because the calibration was done for catchments up to 500 square kilometers, because the resolution of the model is 5 kilometer pixel size. This for us was a huge actually increase, huge improvement compared to the previous version where the limit was actually 5,000. So we are getting there. We are going higher and higher resolution, but we recommend 500 square kilometers in terms of minimum catchment size. We do also provide the information in terms of river network up to 250 square kilometers, but that has to be taken with care, being advised and being mindful that the calibration was not done for so small catchments. And in terms of calibration points, that's true. We have 700 roughly more calibration points compared to the previous version because we moved from 1,200 to 1,900. And a lot of points are actually in Africa, thanks to the collaboration with a group of researchers that decided to share the data with GLOFAS. What we observed is that, I mean, the plot that I showed was just the calibration used for all the time series, because since we don't have the same calibration period for all the stations, but we use what we have, so we cannot really run a neat validation. Regarding the question of the relationship between the performance and the catchment area, I expect that there is a relationship. However, since we put this in place only on the 26th of July, this kind of assessment, like deep dive assessment, are still to be done. But from what we saw in the calibration, yes, the larger is the catchment, the higher is expected to be the accuracy. But there are exceptions. If I have in mind the orange catchment, where there are a lot of dams, where maybe upstream you have a small catchment without a dam, and there you have a better performance. So there are several factors that need to be accounted for.
Thank you. Yeah, is there any question, comments to Stefania from the audience? Just don't be shy, raise your hand or just open your mic and you ask a question. If I have another question, I have the second question for you. Okay, so I will ask the second question. It's about the reservoir. You mentioned that you're collecting information from reservoir, and I would like to know how do you deal with that? Because okay, you have a reservoir, but it's it's really complicated to forecast. I mean, to simulate in your model, because there is a human impact behind. I mean, when they open the dam or when they close the dam. So even if there is a reservoir, or is there a way to use the data from the reservoir, or it's just you want just to map all the reservoir?
That's another very key question that we are investigating right now. What we have done so far, we mapped the reservoirs, and in the hydrological model, there is a routine that models the behavior of the reservoir based on the level of filling. And it's actually meant to reproduce a reservoir which was built for flood protection. So we store water, and then when the flood is coming, we release it slowly. However, we very well know that this is one case, because there are reservoirs for hydropower production, for irrigation purposes, and so on. And on top of that, as you mentioned, there is the manager decision. So there is a sudden human intervention that opened the dam, and that's something that your model cannot predict. So we are looking on one side to increase the number of reservoirs, at least to better represent what is happening in reality, because we are missing a lot of reservoirs. And on the other side, we are looking into solution to actually account a little bit more, at least for several usages, several purposes of the reservoir. But this is a research question that we are investigating right now. And maybe to another idea, which is this is just really an idea that it's floating around in our team, maybe to use altimetry from satellite, so water level altimetry to inform the system. But what is planned is to increase the number of reservoirs, to increase the accuracy of the representation of reality. How we will change the model, that's still under discussion, almost a weekly discussion for us.
No, okay, thank you. Yeah, I can understand that it's the first step already to have already the map, and then we will see how you can manage. I really understand. I completely understand the point. Questions from the audience? Don't be shy. Is there any question? That was so clear. That was okay. So what we can do is is to go ahead to continue the presentations, and then maybe with the example provided by by Vijay, maybe participants will come back to question to Stefania. If you can stay with us, Stefania. So basically, Vijay, if you can take the floor. So now the idea is to switch into kind of operationalization of this, and how we can also provide some information of GLOFAS into the ClimSA station. So the floor is yours, Vijay, for a very brief presentation.
Hi again. So let me, before going to show on the Jupyter Notebook, I would like to clarify something which I missed during our last presentation, last UaF meeting, is that to explain about the notebooks, the previous notebooks which we created, which is very independent of the products in the ClimSA station. So I would like to explain about that again today. So as you already know, some of you, I believe, the ClimSA station has the different pillars where we are working on. One is the data acquisition, as you could see in this presentation. So the data acquisition and then the data ingestion, where we gather the data from the different source and then ingest them in the ClimSA station, which then can be utilized by the data analysis, then the fitness for purpose tool, the impact toolbox, and then also in the Jupyter Notebook. So of course, either the directly ingested data can be used for the data analysis or quality assessment, or also you can make available the automatic processing with which you derive different indicators and then make it available in the ClimSA station again for the data analysis or quality assessment and further GIS things. But what we explained during our last UaF user meeting is or the climate projection, which is where we don't ingest any of uh, the climate projection data because they are voluminous, and then we are not going to create a data source to directly ingest the data uh, in the ClimSA station, and then which can be utilized from the Jupyter notebook. So only you have a specific requirement of the climate projection data, you have to write us to know, okay, this is a particular product, you are interested in Codex or the SEMIP6 or for this particular region of interest or this particular time period, then we can specially tailor the product for you, tailor the Jupyter notebook for you, and then make it available on your system. And then it is again independent of the system, the version you have currently. So it doesn't really rely on the ClimSA station latest version. It's not necessary you need a new version of the ClimSA station to use things, both for the climate projection as well as for this GLOFAS system, because currently we just made available the Jupyter notebook, which is independent of the products from the ClimSA station through the WMS service, which I'm going to explain. So if you say, okay, you want to explore the GLOFAS system, you can go to the GLOFAS system map viewer, which Stefania showed you. You can either see the list of products and then come back to it saying, okay, these are the products you are interested in, and you want to overlay some of the existing products in the ClimSA station. Then we can create a specific Jupyter notebook specially tailored for you, and then make it available on your ClimSA station Jupyter notebook for the analysis. So I hope this clarifies some of your doubts, because it is not going to go through this chain of data acquisition and data ingestion currently. But let's say if most of you are interested in having some of the products described by Stefania, then we are trying to collaborate with them to make a normal service through the data acquisition, data ingestion, and then also the processing. If you are interested, this can be done. But currently, we are not planning to do that by default in our upcoming version. So only through the request, we are going to make available this product. So this is a quick introduction of how we are going to implement things in the ClimSA station. And especially for this GLOFAS product, I quickly created just one particular slide, how we take the products and the services from the GLOFAS. So I would like to thank Giuseppe, who provided the service for us. So from the GLOFAS system, we use the WMS, that is the web map service, what they available as open, and then implemented Jupyter notebook, which can visualize only a couple of products, like flood summary, the rapid impact assessment. So we thought these are the products which can be used immediately, because it is a final derived product, so which doesn't need further analysis like time series or generating graphs or doing a fitness for purpose. So it is not necessary to do this kind of analysis for these products. So we made available only through this web map service, which is basically Fino. It is a OGC standard. So that is how we made available, and also these services can be integrated in your system if you are interested in. So going to the Jupyter notebook, this is the Jupyter notebook, which will be also part of the upcoming release. But if you immediately need it, write to me. I can make available this Jupyter notebook especially for you, so that you can have things on your ClimSA station. So as you could see that it's made of a little bit IPy leaflet libraries, where I added some of the indicators like rapid impact assessment, and then the seasonal outlook of river network, and then drainage network, flood summary days from 1 to 30 days. And also for quick example, I also made available the soil moisture information. I don't know if it will be relevant for you, but this is soil moisture information is coming from the ClimSA station. So similarly, if you say, okay, these are the indicators you need from the GLOFAS and these are some of the indicators you need from the ClimSA station, then we can create such a notebook for you and then make it available especially for you. So we request you to come back to me to ask about what is your need. So here, these are the only indicators we made available, and you see in the right bottom corner, there is also a slider to select the date and the month. So for example, when you load the system, it automatically point to the current day or the day before. So that is yesterday, so 10th of August. And then I select the rapid impact assessment. As you could see, I selected this product, and then you see there is um, um, information, and then also the legend saying it has a low impact in this region near Niger, and then a little bit more impact, the medium impact in close to Malawi, so which is affecting 10,000 to 100,000 people. So this is a kind of information you read from the legend, but I let you to use the system also from the GLOFAS to have more indicators. So you can use the slider to change a little bit the months so that you see the instant changes. Of course, you can use the date to see the changes. So with this service, automatically you can visualize the information what you request for the months of the rapid impact assessment. And similarly, there is also uh, the seasonal outlook of the river network, which gives the information about the probability of high flow, probability of the low flows in different probabilities. So as you could see, the bluer regions are with a higher probability, and then with one of the orange or the lower probability. So you can also go to different months so that you see slightly things are changing. So this is how you can identify the things. So let me go to the current month, and then also there is the flood summary. Flood summary is quite um, um, something I can uncheck the. So you see the flood summary again, and then similarly the drainage network. So on top of it, you can also overlay the soil moisture coming from the ClimSA station, and then overlay also the other products like the rapid impact assessment. So this is again just quick example to show you how you can use different system implementation on the ClimSA station to quickly benefit your needs. So that's from my side, and I request you to write us to know what is your needs exactly, so that we can create something specific for you.
Thank you,
Thank you.
Vijay.
Yep.
Thank you very much. Yeah, just mentioning that it's really a quick example of what we can implement and how we can link the GLOFAS product into the ClimSA station. Of course, the list of variables that Vijay shown is not the only one that could be included. I mean all the data sets could be implemented into the ClimSA station, and the idea is to, I mean, the three advantages I would say is to first, you can directly tune based on your needs. You can identify the products that could be interested from GLOFAS, and you can add it into your system. So in the very large list of products, maybe in your region you're more interested into monitoring the floods or the short-term or the long-term forecast based on what Stefania presented, or what is available on the system. And the second big advantage I would say is it's to facilitate the access. So basically, instead of looking into the web portal and on the ClimSA station, the different informations, you have everything available on the ClimSA station. And of course, if you need more information because you detect a specific and extreme event, or you detect something very important, you can go to the GLOFAS website where you can get the full access to the data, full variables, etc., and so on. And the last advantage is an example provided by Vijay is you may be interested into merging different information coming from GLOFAS and from other data set that are available into the ClimSA station. And thanks to the Jupyter Notebook, you can also add different layers and having different information that could create a very robust information for your bulletin or your service. Thank you very much, Vijay, for the presentation. And of course, we're waiting your feedbacks, partners, the RCCs or National Weather Services, to implement a more advanced system. In the chat, there was a question from Anthony. So maybe Anthony, you can open your mic to ask your question. Anthony Wanti.
Okay, thank you.
Hello, Anthony.
Hello, Christoph and everyone. I was curious to know how GLOFAS handles flood protection infrastructure, because in some major rivers, which are known to be cause of floods in some areas, there are some barriers that have been established. So is this taken care of? And from this other presentation, I think I appreciate the flexibility that it will offer us in doing more analysis on the data. So this is appreciated. Thank you.
Thank you, Anthony. Thank you, Anthony. Stefania, if you...
Yes. Thanks. That's a very good question. Yes, the flood protection are taken into account. We use a global publicly available database. I will post the link, the reference in the chat in GLOFAS for the moment. So they are accounted, but we account for the information which is globally available.
Thank you. Thank you. Yeah. Maybe there are other questions. Okay, thank you. Yeah, we have the link in the chat. Thank you, Stefania. I don't know, Innocent or Gavin, you want to ask a question? No. I don't know. I see you.
No, good afternoon. For my
Hello?
side, no question.
Hello? Hello? Go ahead. Go ahead.
No, for my side, no question. I am so thankful.
Is there any question or remarks regarding the two presentations, both the data sets or the presentation?
I think Gavin was about to intervene, but I see him muted now. No?
He said no question. No question.
No, he said
Okay,
no question.
that's my misunderstanding, sorry.
Yeah, maybe I could ask Vijay that when do we expect to have these notebooks available so that we could also interact with them and let you know how we are proceeding with them? Thank you.
Okay, I can quickly make available, but I would like to know what are the exact indicators you are interested in. So what I presented is just an example and what we thought might be of your interest, like the rapid impact assessment and the seasonal outlook. But if you can write me the list of products you're interested in from the GLOFAS system. So first you have to look at the GLOFAS system because they have wide variety of products. So most of them are available through this WMS service. So first, I request you to have a look and then get back to us and tell me, okay, these are the products you are interested in. I can tailor a particular notebook for you and then send it to you. So that is the idea. Is it okay?
Thank you. Well understood.
Okay. Thank you.
Any question, comments, needs, specific needs?
Yeah, maybe I can intervene. It's a bit a follow-up of a question of Anthony, because you know, the Jupyter notebooks for us are really a way to prototype, to develop new products, also new features, and I think actually we should find a way to share them. Because you know, when we update the station, it goes through a release. So most of you, they have the latest 1.14, but it does take time for validation and deployment, upgrade, and so on. While the notebooks are much more flexible manner and opportunity to share the results. So I think we will go in this direction, Anthony, to maybe to send you what was done now already, because I mean, that doesn't make it really hard for you to have it. And maybe also to think also in view of the next forum meeting we are going to have, to think of a way of sharing in some repository the notebooks we implement for you to look at them and maybe suggest modifications. So I think your request is relevant, and we will try to accommodate it as soon as possible. Thanks.
Thank you, Marco, for the clarification. Is there any other points? Yeah, I don't know if. Okay, so thank you again, Stefania. We can also open the floor for open discussions about the next UEF. If you want, we propose a specific thematic. If we want to propose, if you want a specific training, I mean a webinar, or I don't know, a presentation of a specific product, a specific tool of the ClimSA Station. If you want something related to the data or the technological presentation, just let us know, or if you have a comment on the data. Is there any open question related to the global ClimSA, all the ClimSA Station, not necessarily on the topic we discussed today? You look very shy today. Okay, if I'm gonna close. So if not, we're gonna close this UEF. For the moment, we didn't plan a new one, since you know maybe that we will have the ClimSA forum the week of the 11th of September. So we don't know if we're gonna do a UEF the week before. Maybe that would be one solution. We will keep in touch for that. And if you have any questions, remarks, don't hesitate to contact us. Stefania for or in the GLOFAS website for GLOFAS points, or of course Vijay, Jurgen, Marco, or myself for the ClimSA Station. Thank you, everyone. We're going to stop now this UEF. Thank you again, Stefania, for your very, very nice presentation. And the video will be put on in our YouTube channel, I think this afternoon. So for those that didn't attend the beginning of the session, or colleagues that didn't came today, you can also tell them that the video will be available. Thank you, everyone. Have a good afternoon, good weekend, and we keep in touch. Thank you.
Thank you very much.
Thank you. Bye-bye.
Bye.
Bye.
See you. Bye.
Vijay. Ciao.
Yeah. Hi, Cecil.
Thank you. Bye.
fine. Thank you. You?
I'm not fine.
Okay.
We will talk after everyone has left.
Okay, sure, yeah. We can also have a separate meeting if you like.
Yes.
You can
Yeah.
stop recording. Did you
Yeah.
stop recording?